In this video, we're going to continue our discussion of confidence intervals, and more specifically, we're going to try and interpret what a confidence interval truly is. So in the previous video, if you watched it, we went through a sample proportion of 20% of adults drinking seltzer. We came up with let me just highlight a couple things here. We came up with a standard deviation of roughly 3%. Okay, we used our margin of error, and then we came up with an interval of 14% to 26%. And we said that I'm 95% confident that the true population percentage of adults who drink seltzer is between 14% and 26%. Now, this statement is based off of one sample and one sample only. Okay. The question asks us, let's say we had 100 students in our class, each do the same activity. Okay. And we each asked them to sample a bunch of different people to answer this question. What we would find is in those 100 samples, do you think we would all get 20% as our sample proportion? No. Some of us might get 21%. Some of us may even get something like 28%. We may get something like 17%. Okay, I'm just making these numbers up. But what they all would have in common is they would share the same width, okay, because this is purely based on our standard deviation and our sample size. So our width here is exactly 12%. So what I mean by that is this interval would be between 15% and 27%. For 28%, that interval would be between 22% and 34%. And then for 17%, we would see that go from 11% to 23%. Notice how I keep that width of 12% at all times, okay? And now these are just three of them. We'd have 97 more. But out of these 100 samples, okay, we would say 95 out of 100 would capture the true population parameter. Okay, another way to think about it is if we were to calculate the true population parameter of flipping a coin and getting heads. We know that that's 50%. But let's just say 5 of our samples, in one of them we get the confidence interval of 52% to 62%, or we get a confidence interval of 39% to 49%. Okay, these are two examples of intervals that do not capture the true population parameter of flipping a coin and getting heads, which we know is 50%. Okay, to make this concept sink in just a little bit better, I'm going to use an app that I think explains this topic really well. Okay, so I want you to go over to your rossmanchance.com, and then I want you to click on simulating confidence intervals for population parameters. It's the fourth option down on this menu over here. So we're going to click on this, and you'll notice that it has a couple options. Okay, we're looking at proportions, we're looking at binomial, and what that means is binomial means there's one of two choices, right? Either win or you lose, you either get heads or you get tails, you either have a black pen or a blue pen, okay? Now, this pi symbol right here represents the sample percentage, okay? I should say the population percentage. In this case, is 50%, and we're going to use this to simulate the act of flipping a coin and getting heads, where heads would be a success, tails would be a failure, okay? And this n is how many times we're going to flip the coin, okay? And we're going to calculate 95% confidence interval. Okay, so here's how this thing works. If I click on sample once, okay, in my most recent sample, it gives me a tally. Now, it's difficult to see because we're so zoomed out here, but if I were to count each one of these little blue lines right over here in this failure column, I would count out 45 of them. And then over here to success, I would count out 55 of those. I had a sample proportion or sample percentage of 55%. We know is a little bit higher than what the true population parameter is. But let's pretend, again, I'm an alien, I'm new to the planet, I have no idea that flipping a coin and getting heads or tails is a fair shot. So I use that 55% and I use that to build a confidence interval, okay? So I would look at 55% plus or minus 2 times the standard deviation, which would be the square root of 55% times 45% all over the sample size of 100. Now, we're not going to spend the time to do that math right now because this app actually does it for us. If I come over here and I hover over and I click on that line, okay, if you notice, let me try and zoom in a little bit here so we can see better. This dot represents the middle of 55%, and this is my confidence interval. I go from 45 all the way back to roughly 65. Okay, so 45 to 65 and then 55 in the middle. That tells me my standard deviation is roughly 10%. Okay, now let me zoom back out. Does this confidence interval capture what we know is the true population parameter? In this case, 50%. It does. Okay, let's do another one. Okay, if I go to one interval, okay, same thing. We click on sample. All right, this one I got 51%. Okay, again, here's my interval over here. Notice how it's the same width. It goes from roughly 41% to 61% with 51% in the middle, and it does capture the population proportion. I'm 100% so far. Now remember, I'm doing 95% confidence, so in the long run, I should get one time out of every 20 times, I should get one that is off. So let's keep going and see if we get that. Let's do another sample. Okay, this one was 48%. We see it's a little bit less. Okay, to compare a bunch of them, let's do 50 of these. Let's do 50 intervals of all size 100. And you're going to see how they stack up, and you're going to see how the width is all the same. If I click on sample, okay, I really like the way this works. It shows the most recent sample. The most recent one was 47%. Okay, it looks like it was this one right up here. All right, 47% being in the middle, 37% being my lower bound, 57% being my upper bound. So my standard deviation is 10%. And I also like, if you come down here to the bottom right, it gives you a histogram of the sample proportions. You can see a couple outliers here. Okay, this one looks like the sample proportion was 39%. This one was 40%. What's important for us is to look at those and to see that we have 2 out of 50 that did not capture the true population proportion. All right, let's click on it. This one goes from 30%, ooh, very close to 50%, but just underneath of it, okay? And if you click, when you click on it, it lists the sample over here. We had 40%, so 40 out of 100 flipped and got heads. This one looks like it's even lower, 38 out of 100, so a very low sample. My confidence interval is between 29% and roughly 48%. Okay, and you see how I have about 95% that contain the interval. Let's do 100 more and see what we get. Click on sample. All right, again, here are my values, and I see roughly 93 out of the last ones I did out of 100 contain the true population parameter. These ones in the red are on the outside, and then my running total 94%, pretty darn close to 95%. Okay, so that's what a confidence interval means. What it truly means is if I were to conduct a confidence interval X amount of times, let's just use the word 1,000. Let's say I calculate 1,000 times, roughly 950 of those would capture the true population parameter. The other 50 would not. 95% of the confidence intervals capture the true population parameter. In this case, is 50%. The other ones do not. Notice how they all have the same width, okay, because standard deviation is primarily based on sample size.